All right, today we are going to do trig word problem stations. So our focus for learning for this lesson is I can use trig ratios to solve word problems. So we're going to take everything that we've been learning about our three trig ratios, sine, cosine, and tangent, and use those functions to help us solve word problems. Oops. All right, so when we're doing word problems, we're going to have to talk about two things, the angle of elevation and the angle of depression. So when we were doing the activity in class last week where we were using the clinometer to measure the height of tall objects, and then some people use the clinometer to measure the height of objects that were shorter than they were, that's where angle of elevation and angle of depression came into play. So angle of elevation, when looking up to an object, the angle of elevation is formed by an observer's line of sight and a horizontal line. So here we have a person, they're looking up at the top of the lighthouse. Here, our angle of elevation is the horizontal line that is formed between this person's eyes and the lighthouse. So here we have the angle of elevation. It's the angle that's formed between this person's eyes and the lighthouse and their line of sight. Now, angle of depression is when looking down to an object. The angle of depression is formed by an observer's line of sight and a horizontal line. So here we have the lifeguard. He's looking down at this person in the water. So the angle that's formed by this horizontal line with his eyes and this line of sight down to the swimmer, that's our angle of depression. Now, in a diagram, the angle of depression is congruent to the angle of elevation because they are alternate interior angles. So alternate interior angles, that's a word that we've learned before. If we look at this picture here of the lifeguard, our yellow line is our line of sight. Now this green angle here is our angle of depression. It's going to be congruent to the angle of elevation. So the angle of elevation in this picture would be this green angle right here, the angle that is formed by the swimmer's line of sight and the horizontal line of the water. Now, remember, these two green angles, the angle of depression and the angle of elevation, they're going to be congruent to each other because they are alternate interior angles. So they are alternate because they are on opposite sides of the transversal. So our line of sight is acting as our transversal. And they're interior because they're inside our two horizontal lines. So the sight line of the lifeguard, the horizontal line with the lifeguard's eyes, and the horizontal line with the swimmer, those are our parallel lines. So angle of depression and angle of elevation are congruent to each other because they're alternate interior angles. They're on opposite sides of the line of sight, which is our transversal here. That makes them alternate. And they're inside our horizontal parallel lines. All right, so now we're going to solve a trigonometry word problem. So the directions say, draw a diagram and use it to solve the problem below. Round your answer to the nearest tenth. In every problem that we're going to do today, the first step is going to be to take the information the problem gives you and draw a diagram. So you want to draw a diagram and label it with the given information. That's going to make the problem so much easier. So, Max built a skateboarding ramp that is 16 inches high. The angle formed by the ramp and the ground is 21 degrees. What is the length of the ramp? So first thing we need to do is we need to draw a picture. So we're going to draw a right triangle here because when we're working with trigonometry, we're working with right triangles. Now, they tell us that the ramp is 16 inches high. So the distance from the ground to the top of the ramp is 16 inches. So you're going to draw your right triangle and you're going to label the 16 inches on it. The angle formed by the ramp and the ground is 21 degrees. Well, this is a skateboarding ramp, so we obviously know that this orange piece here, this is the ramp. Okay? So the angle formed by the ramp and the ground is 21 degrees. We're going to write that on there. What is the length of the ramp? Well, the ramp we just went over is this diagonal orange piece. We don't know the length of the ramp right now, So we're going to represent it with the variable x. So we took the information from the reading and we put it on the picture. The ramp is 16 inches high. The angle the ramp forms with the ground is 21 degrees. And we don't know the length of the ramp. So we're going to use our variable x to represent that. Now that we have all the information from the problem on our picture, we're going to figure out which trig function do we need to use. So which ratio do we have the pieces for? So if we look at our 21 degrees, that's our theta. It's our reference angle. In relation to this theta, the 16 inches is our opposite piece because it's the leg of the triangle that does not touch our reference angle at all. So we have the opposite piece. And then x is the hypotenuse because remember the hypotenuse of a right triangle is the longest side of the triangle and it's across from the right angle. So if we take our pencil and we draw an arrow from the right angle across, we hit the hypotenuse. So then we have to think out of sine, cosine, and tangent, which one of those ratios uses the opposite side and the hypotenuse. And if you don't remember that, you can just look right on your state test reference sheet. Remember, those ratios are on the state test reference sheet. You do not need to memorize them. You just need to know how to use them. So for opposite and hypotenuse, we're going to use the sine ratio. So the sine of some angle theta is equal to the opposite piece over the hypotenuse. Once we've determined which ratio we're going to use, now we're going to substitute in the information we know and solve for the information that we don't know. So we already said 21 is our reference angle. 21 degrees is our theta. So we know that the sine of 21 degrees is going to be equal to the opposite side, which is 16, over the hypotenuse, which is x. Then remember, in order to solve this, we need to turn it into a proportion. So we need to take the sine of 21 degrees and put that over 1. By putting that over 1 and turning it into a fraction, we now have a proportion that we can solve by using cross multiplication. So remember, when we cross multiply, we take the numerator of one fraction and multiply it by the denominator of the other fraction. And then we take the denominator of the first fraction and multiply that by the numerator of the second fraction. So we're doing cross multiplication. So when we do that, 16 times 1 is just 16. And then when we do the yellow cross multiplication, that turns into x times the sine of 21 degrees. Now we need to take this and we need to solve for x. So right now, x is being multiplied by the sine of 21 degrees. So to undo multiplying by the sine of 21 degrees, we're going to divide both sides of our equation here by the sine of 21 degrees. When we do that on the right-hand side here, the sine of 21 over sine of 21, that makes a giant 1. And then on the left-hand, so we're just left with 1x. And then on the left-hand side, we have to take 16 divided by the sine of 21 degrees and type that into Desmos. So remember, when you're typing this into Desmos, you need to make sure your Desmos is in degree mode, or else you will not get the correct answer. So you need to click that wrench in the top right-hand corner and scroll all the way down to the bottom and make sure your Desmos is in degrees. Then you can do 16 divided by the sine of 21 on Desmos, and we get that x is equal to 44.6. Remember, we need to round to the nearest tenth. Excuse me. So this answer is already rounded. Desmos is going to give you a longer decimal. You need to look at it and make sure you round it to the nearest tenth. All right, so what we're going to do today is I'm going to post Trig word problem stations on Google Classroom. There are 6 stations, I believe, and each station has 2 questions. You're going to show all of your work for each station on the packet provided to you. So for each problem, you should be drawing a picture like we just did in the example we did together, labeling the picture, so taking the information from the problem and putting it on your picture, and then setting up your trig ratio, showing your cross multiplication, and then typing it into Desmos to solve and writing down your final answer. For all of the station problems, you're going to round your answer to the nearest tenth. You can use Desmos and your state test reference sheet.